Hello, I'm Richard Woodgate and I work as an engineer in the electronics team at Cosworth, which means I help design and build things for race cars like computers that control things such as engines. At the moment, my job is to develop the special hybrid technology that will be used in the British Touring Car Championship, the biggest race series in the UK. The race cars are based on normal road cars with a few important modifications designed to make them faster and safer. This year, all BTCC cars will be powered by hybrid technology. Some of you in the room might already have ridden in a hybrid car. More and more road cars are now using hybrid power. We'll get into exactly what hybrid means in a minute. Here at Cosworth, we are experts in this kind of technology. So the British Touring Car Championship asked us to develop the hybrid system that will be used in every car on the grid, and it's my job to make it work. Transport is a key part of society, and humans have always looked for ways to move more effectively by using energy for motion. 150 years ago, you might have travelled by foot or by horse, in each case using the energy in food to provide energy for motion. We've harnessed wind and also used steam to power vehicles like trains and boats. But when the internal combustion engine was invented, it meant we could make smaller, petrol-powered vehicles for us to use every day, like cars and motorbikes. In the last 25 years, new technologies have emerged that use electricity to provide a more efficient and cleaner source of power for transportation. These include hybrid systems where electricity is used to assist a petrol engine, fully electric vehicles that are only powered by a battery, and even hydrogen fuel cell technology that uses hydrogen gas to make electricity that powers the car. The term hybrid simply means bringing two things together. So in a hybrid car, we combine a normal petrol-powered engine with an electric motor and battery to move the car. There are different types of hybrid systems. A plug-in hybrid charges its battery by plugging the car into an electrical socket, just like charging a phone or a tablet. A self-charging hybrid charges its battery by recovering energy when the car slows down and by using the engine also. And a range-extended hybrid uses an engine to generate electrical energy which powers the vehicle. The engine itself is not connected to the wheels, it is only used to produce electricity. The hybrid system in the BTCC race car has a slightly different aim to that of a road car. In a road car, the electrical energy is usually used to make the car more efficient, meaning it will use less petrol and create fewer harmful emissions. In a race car, you want to go as fast as possible, so the electrical energy is used to boost the car's performance on track. In short, the BTCC car's hybrid system is an efficient way to make the race car faster. The hybrid system in the BTCC car uses a battery and a combined motor generator. The battery stores the electrical energy for the system. It is located on the floor of the car to help keep the centre of gravity low, which is important in a race car so that you can go through corners as quickly as possible. The hybrid motor connects to the BTCC car's gearbox. During a race, it delivers a boost of extra power when the driver pushes the button to help overtake the car ahead. This concept is called push to pass, and each driver will only be able to use the electric boost for a few seconds each lap to keep the racing close and exciting. When the BTCC car brakes, the hybrid motor begins to function as a generator to produce electricity. Normally, the brakes use friction on its own to slow the car. By pushing a brake pad onto a brake disc, you create friction which slows the car by turning the moving or kinetic energy into heat energy. On the BTCC hybrid car, some of the kinetic energy during braking is used to spin the motor generator, generating electrical energy that goes back into the battery. This also has the effect of slowing the car down. The rest of the kinetic energy is turned into heat through friction of the brake pad on the disc, as normal. With a recharged hybrid battery, the driver is ready to attack again on the next lap using push to pass. The function of the hybrid system can be demonstrated with an elastic band powered cotton reel. As you wind the elastic band, you are turning kinetic energy into stored or potential energy. This is the same effect as when the BTCC car brakes and the generator converts kinetic energy into electrical energy stored in the battery. When you release the elastic band, the stored or potential energy is changed back into kinetic energy, resulting in motion. The cotton reel moves along the surface. This demonstrates pressing the BTCC car's push to pass button. Stored energy in the battery is changed into kinetic energy, giving the car a boost of power that makes it faster. We'll now look at making one of those. Okay, the parts required to complete the challenge are a cotton reel, preferably pre-prepared with a slot, some rubber bands, a pencil and toothpicks. First thing to consider with your models is how many turns you'd like to put into your motor, because this will determine how powerful an output you get, whether or not you use a small elastic band or a large elastic band. Begin making the model by breaking a toothpick to fit inside of the groove of your cotton reel. Make sure that the toothpick can fit within the groove. Once you know your toothpick fits, take a rubber band, place it over the toothpick and pass the rubber band through the centre of the cotton reel. This part is fiddly, but once complete, it should look like this. So your next step is to use either the pencil or the lollipop stick to create your chassis. Hold your elastic band so that you have a loop and pass your pencil through that loop. Maintain some tension so that you don't lose your toothpick. Then begin to wind the pencil to begin to preload the energy you're going to put into your motor. We're now beginning to store energy in our cotton reel by using kinetic motion. Just like the BTCC car recovers energy from the kinetic motion from the wheels. Just like a real car, there'll be a maximum amount of energy you can store. And be careful, because if you try to overstore energy, you will break your elastic band. So with the elastic tight and the energy stored, we're now ready to see what it'll do. You can test a different amount of rubber bands once you release the car. Well done everybody. I hope you have all had as much fun as me building our miniature hybrid racers. And as you will have seen, different designs can affect the speed of your race cars and the distance that they will travel. And did anyone notice? Just adding more power isn't always the answer. Stability and control also count. But for now, it's goodbye from me. Thanks for trying so hard, and who knows, perhaps we will find some of you working with us on projects like the next generation of British touring cars in the future.